you will find this type of, instead of this direction, you use this curve instead. Okay. So when you study the material, we select the suitable range of the potential to study. First of all, we have to know the corrosion potential, and then we can measure the corrosion polarization resistance of the material in the very narrow potential range. Then this narrow potential range doesn't affect on the surface of the material. And for the, here this is total plot. You can enlarge a little bit of the, you can enlarge a little bit of the potential range, like 100 millimeter around the corrosion potential. So this we can, in this potential range, you can have a corrosion rate. And for the metal that have passive film, you have to extend more until the pitting passive breakdown. We call breakdown potential. So this one is called like potential dynamic and phase polarization. So this is the example of the test. We have 13% chrome magnetic stainless steel and super 13 magnetic stainless steel. And then you can see that with the unlike element has a higher corrosion potential, that means higher corrosion resistance. And then this is the from the polarization resistance. This is at the zero current. That means at this is the corrosion potential. This is the range is minus 20 millivolt below E corrosion, and then plus 20 millivolt. So after the test, we got the corrosion polarization resistance, and now we can calculate the corrosion rate. This is Tassel plot you have seen before. That we can have the corrosion current and then the corrosion potential. This one potential dynamics. So we have here corrosion breakdown potential as well as the corrosion rate. And we can have a passive range and then passive, high passive. That means during the material has passive film, they still remain corroded at this amount of the current. So the next one is scientific polarization. If we know the pitting potential already, we know that okay, it will pit. If the pit can be repassivate, we can use this technique. So this is 316 in the 3.5% sodium chloride, and then this is the duplex 2205. You can see that the duplex has higher pitting potential and this can repassivate very quickly. But the 316 in like a seawater, it cannot repassivate at all. Now you can select which the material can be used near the seawater. For the next technique that we do is we call electrochemical potential kinetic reactivation, that is short for EPR. So this one we try to determine the chromium depleted area. When you weld it like austenitic solid steel and like supposed to be 304, and when you weld it, this is melting. This is almost melt. That means this is around, in this fusion line is temperature around 1500 degrees Celsius. So that means the temperature decrease when it's further away. So the temperature range is, the dangerous is 800 to 500 degrees Celsius. In this region, the material will, the stainless steel with the chromium, like in this case, 18%. The chromium will diffuse the grain boundary and form chromium carbide at the grain boundary and cause the chromium depleted area around it. So that means along the grain boundary, they have a chromium depleted area. So to determine this one, this is they try to see that, then they analyze the chromium content from this pass through the grain boundary that along the grain boundary that have a low chromium content. If the normal microstructure of 304 here, but this one after they has been sensitized, we call it sensitized, the corrosion takes place all over the grain boundary. So how we can detect it? We use we find the corrosion potential and scan forward until it's from the passive film, and then we scan backward again. We use this current, the peak of the current of we call backward current here, and then divided by the forward current multiplied by 100, you can have the we call degree of sensitization %. So this one we can say that how serious of the problem would be. So another testing is catalytic desponding. We use this for the study the food can. So in this Pouget diagram, you can see that in this range the water stabilized. But when the potential below this line, the hydrogen will be formed, and then the upper this to oxygen will be formed. So we will polarize the material, the coating material, until below this one. So the hydrogen will be formed between the surface. Okay. So the technique, another technique is CIS. We apply the testing, apply the small potential with the alternating current from high frequency to low frequency. We got the result is the both and the Nyquist part. Here we got then we got the equivalent circuit. For example, like this, we have a pure capacitive, and then with the solution can penetrate the coating, and then with the solution can reach the metal substrate. So with the application, this is the application that we use. This is for the test for the different type of the coating and then stainless steel. And then this one we study the passivation technique, like we use the nitric acid and just a polished one without any treatment, and the treatment with sulfuric acid with the hydrogen peroxide, and then we test for the pitting corrosion. This one is again with the welding. With the welding at this point, the welded area cannot be passive at all. This one we study the 321H sensitized at 300 degrees Celsius for this amount of time. You can see this is the 1 hour exposed to the 600 degree. This is 10 hours, but when you do 100 hours, you can see that the healing effect occurs. This one, this is we go out and then testing in the field for the sensitization of the material. This we use for the packaging. We study the packaging and we do a shelf life study for the company. So we with the thin free steel with door and redraw can in the sodium chloride solution, and then we have a BIS. We do resistance, so the resistance of the lacquer as well as the water uptake on the lacquer. This one the annual testing we have the approved lab for testing for Thailand Industrial Standard Institute for this to test method. This one the test for the sacrificial anode that has been used. This one has used for the protect rebar in concrete. This one is the anode to protect the underground pipeline or the structure in the water. This is the test that we done. For the chemical inhibitors testing, now we use different type of the technique. For example, this one for the normal, for the inhibitor testing for oil and gas is a bubble test, thermal stability test, and sand absorption test. This is the test for 48 hours. Here we do without inhibitor, and after we add inhibitors, corrosion will become lower. And then this is a jet impingement test. This is a test specimen with 3 rings, different diameter, and then we project the test solution in the center, and then it will have a shear stress on the surface of the specimen. This is a test setup. You can see that this is before, and then after input the inhibitors, this is the inhibitor concentration in the test system. So this is all for me.
Thank you very much.